Bright Tuty. Every student matters.
Hello students, welcome to your class. In today's class, we are going to learn about angles, we are going to learn about curves and polygons. So let's get started with our today's class. So curves, polygons and angles is what we are going to cover in today's class. Let's quickly check our prior knowledge. So I hope you do remember that in the last class you learned about point. Then you learnt about line segment, you learnt about line, where you learnt about intersecting and parallel lines, and finally you learnt about rays. I hope you remember. Now let's start with curve. Here, let us see how we can define a curve mathematically. A curve is a continuous smooth flowing line. So what does that mean? Say if you have a pen in your hand and you are just sitting idle. Do you start doodling something on paper? What you doodle on the paper, it is an example of curve. For example, here it says that how we can draw them. So if I draw this is an example of a curve. If I draw this is an example of curve. So whatever I'm doing here, these are all the examples of curve. Okay, so I hope you know that if we have a continuous smooth flowing line, it is called a curve.
Look at the animation.
These are all curves. The curve whose starting and end points do not meet is called an open curve. The curve whose starting and end points meet is called a closed curve. The closed curve which does not cross itself is called a simple closed curve. Observe the simple closed curve. It is the boundary of the closed curve. The shaded portion shows the interior of the curve. It does not include the boundary of the curve. Here the shaded portion shows the exterior of the curve. We see that closed curve 2 is made up of line segments only, while it is not so in case of 1. We call closed curve 2 a polygon. A closed curve bounded by line segments only is called a polygon. Let us discuss some terms related to polygons. The line segments forming the polygon are called its sides. The polygon is made up of line segment AB, BC, CD, DA, so these are its sides. Two sides of a polygon having a common end point are called adjacent sides. Other pairs of adjacent sides are BC-CD, CD-DA, DA and AB. We use special names for polygons based on the number of sides they have. A polygon having 3 sides is a triangle, 4 sides is a quadrilateral, 5 sides is a pentagon, 6 sides is a hexagon, etc. The point where 2 sides of a polygon intersect is called its vertex. In the figure, there are 6 vertices of the polygon. The end points of the same side of a polygon are called adjacent vertices. In the figure, the end points of the side AB are A and B. So A and B are adjacent vertices. Here other pairs of adjacent vertices are BC, CD and DA. If we join 2 vertices of a polygon which are not adjacent, the line segment so formed is called the diagonal of the polygon. In the figure, if we join the vertices A and C, we get the diagonal AC. Other diagonals of the polygon are AD, BD, BE and CE.
If this is a polygon, then what is a non-polygon? Look at the 2 images in front of you, right? So here in the first one, we have polygons, and clearly what we see that all these polygons are made up of line segments, right? Now look at the non-polygons and let us see why they are not a polygon. In the first image here, this first image, Clearly what we see is that it is open from one side, right? So the first point to notice is that a polygon should not be open. So I'm just writing it here. Should not be open. So this is the first point to remember, that a polygon should not be open. Now look at the second image here. In the second image, we can see that here we have a curve. We don't even have the line segments. So the polygon should be made up of only line segments. So they should always be made up of only line segments. It cannot be made up of a curve or any such thing. Now look at the third image. What is special about this is that here we see that the two line segments are overlapping each other, right? So let's write down the third point. No overlapping. So this is the third point, that if a polygon has got overlapping side, it is not a polygon. Okay. Now the last one here, the fourth image. Clearly it is a curve. So let's not write it again because it's similar to the second point, that we cannot have a polygon which is made up of a curve. Okay. It should only have line segments. Moving forward here, we are going to learn about sides, vertices and diagonals in a polygon. So we just learned that polygon is a closed figure which is made up of line segments, right? So can you tell me what is the minimum number of lines that we need in order to form a polygon? Can we make a polygon using just one line segment? Is it possible if I put one line segment? Can we call this a polygon? No, it's just a single line. If I say I have two lines, do you think this is a polygon? No, because it is open. So again, this is not a polygon. Now if I put another side here, now can we call this a polygon? Yes, we can, because it is made up of three line segments, three straight sides. When joined together, they form a polygon. And one very important point I want you to notice here is that we need at least three line segments in order to form a polygon. Okay. So this can be a single your objective kind question, that what is the minimum number of line segments that you need in order to form a polygon? The answer is 3. So the least number of sides can be seen in a triangle. Now look at this triangle here. I hope you remember we learnt about how to name the sides, the line segments of a given shape, right? So let us write all the line segments that we see in this triangle. So here we have line segment AB, we have line segment AC, and we have line segment BC. These are the three line segments. These line segments are basically the sides of this triangle. Now let us write down the sides for the quadrilateral here, ABCD. So the first side is AB. The second side we can see is side BC. Then we have side CD and side DA. Is that right? So here we see that in a triangle we have total 3 sides, and in a quadrilateral we have total 4 sides. Now moving to vertices. What is a vertex? So I just said the word vertex. What is the difference? Vertices is a plural word, and if you want to use the singular word, it is vertex. This is for the singular. So the point where two lines intersect each other, it is termed as a vertex. So how many vertices do you see in the first image? We have total 3 vertices. That is point A, B and C. So these are the total number of vertices in triangle. Let us write down the total vertices in the quadrilateral, that is A, B, C and D. Moving to the next one, that is diagonals. Now what is a diagonal? Diagonal is the line segment which joins a particular vertex to the vertex sitting next to its adjacent vertex. Let me say this again. See this particular figure here. Figure 2, that is a quadrilateral. So let's consider this particular point A. Okay. Can you tell me which points are sitting on the adjacent sides of the point A? Clearly point D and point B are sitting adjacent to point A. Can you tell me which point is sitting next to the adjacent point of point A? So the answer is point C. This is the point which is sitting next to the adjacent point of point A. So when we join point A to point C, this particular line segment is referred to as a diagonal. Is this clear? Now similarly, let us draw a diagonal from point B. So to this particular point B, we have point A and point C that are sitting to the adjacent sides. Now the point which is sitting next to its adjacent point is the point D. So let us join B to the point D, and what we get is a diagonal. So let us write down what all diagonals we see in this quadrilateral. We see diagonal AC and diagonal BD. So these are the two diagonals in this particular image. Can you tell me, is it possible to draw a diagonal in the triangle? Is it possible? The answer is no, it's not possible. Why? Because here, if I start drawing a diagonal from point A, I don't see any point which is sitting next to its adjacent points. I just see the adjacent points in this image. I don't see any other point which is next to its adjacent point. So here, another one thing that we are going to remember is that if we want to draw a diagonal in a polygon, the minimum number of sides that it should have is 4. Okay, so only you will observe diagonals starting from the quadrilateral. Okay, not in a triangle. Let us see this particular image here. We have just discussed about triangle and a quadrilateral. So look at the first one here, polygon, that is a triangle we are talking about. We have total number of sides 3. So if the total number of sides are 3, so the number of angles is also 3 and the number of vertices is also 3. The number of diagonals is 0. I hope this is clear. We just discussed about this. Now coming to quadrilateral. Number of sides is 4. Number of angles is 4. Number of vertices is 4. And number of diagonals is 2. Now coming to the next shape, that is a pentagon. What is a pentagon? The pentagon is the shape which is made up of 5 sides. Okay, so 5 sides. Then how many angles? It will have 5 angles. How many vertices? It will have 5 vertices. And how many number of diagonals? Let us count this. Look at this image here. Here, say this is point A. So to the point A, say point B, C, D and E. So to the point A, we see that point B and point E are sitting adjacent to it. So which points do we see that are sitting next to the adjacent point? So it is point C and point D. So how are we going to draw this particular diagonal? We are going to join A to the point C and we are going to join A to the point D. So these are the two diagonals that can be made from point A. Similarly, let's do this from point B, as A and C are the adjacent points. So we will join B to the next point, that is point E and point D. Now the last diagonal that can be drawn is from C to E. So we see that total 5 diagonals are possible to draw in a pentagon. Now talking about hexagon, which has got 6 sides. So there are several names for polygons. Starting from 3 sides, it is called triangle. Then for 4 sides, it is quadrilateral. If it has got 5 sides, it is known as pentagon. For 6 sides, it is hexagon. For 7 sides, it is septagon. For 8 sides, it is octagon, and you can relate octagon with octopus. It is also named because it has got 8 legs. So it is octopus. Here, if we are talking about a polygon, so 8 sides is octagon. If we have got 9 sides in a polygon, it is called nonagon. If it has got 10 sides, it is called decagon. Okay, so and on you have got several names, but it's okay that you remember at least 10 of them. Okay, now coming to hexagon, it will be great that you try to draw a hexagon yourself and see how many diagonals you can find in a hexagon. So let me just draw a hexagon. It needs to have 6 sides in it. Okay, so this is a hexagon having 6 sides, so 6 angles and 6 vertices. Shall we draw the number of diagonals in it? So here, starting from this point, we have 1, 2, 3, 4, 5, 6, then 7, 8, and do I have another one? Yes, 9. So we have a total of 9 diagonals in a hexagon. Make sure that when you try to draw this, you use a ruler and pencil in order to have straight lines and a clear image. Now, what have we learned so far? We have learned about curves, we have learned about polygons, and we have learned about sides, vertices, and diagonals. Let us try some questions to get a better understanding of what we have learned.